Hello, Year 4. This is Maths with Mr. Bowes on Wednesday, the 20th of January 2021. Today we're going to be looking at fractions. Before we do that, though, I think we can just jump straight into your answers from yesterday. These are the answers, so mark your work from yesterday. Just pause the video and mark it now. You've got the, I think it just starts with spicy up here, and we've got spicier going down there, and spiciest at the bottom there. Okay, warm-up activity is just to do converting different weights, units of weight under measures. We've got grams and kilograms. This builds on the units that we were measuring and converting before, which was centimeters and meters and millimeters, units of measure. So on this card, all of the weights are actually paired off. So you can see the equivalents. That is to say, weights that are equal to each other. So at the top, you can see 2,200 grams is the same as or equal to 2.2 kilograms. Underneath, we've got 1,700 grams is equal to or equivalent to 1.7 kilograms. So there's a mathematical rule you can use to convert from one unit of measurement to another. If we have a certain number of grams over on this side, say, for example, we've got 1,700 grams, and we want to convert them into kilograms on this side, which is 1.7. The rule in maths is that we would have to convert, so if we're going in this direction, see my arrow pointing from grams towards the kilograms, I would have to divide the number by 1,000. So it's division by 1,000. If I had some kilograms, somebody told me what the kilograms are, in this case it's 1.7, there's a maths rule that you have to do to change it into grams going this way. Can you see what it is? It's the multiplication. It's getting bigger and it's getting 1,000 times bigger. So if somebody told me what the kilograms were and I wanted to convert it into grams, I would multiply it by 1,000. So you're either multiplying by 1,000 to change kilograms into grams, or you're dividing by 1,000 if you want to change grams into kilograms, which is why I've got my arrow going in this direction here. Okay, and you can see some equivalents. So just read these out to yourself, pause the video and read these out to yourself. I've done the first two. The next one is 550 grams is equal to 0.55 kilograms. 1,400 grams is equal to 1.4 kilograms. So just look at the other ones. You can see that this one here, for example, is showing us 0.5 of a kilogram, and another way of saying that is half. And we notice that 500 on this side is actually half of 1,000, because 1,000 grams equals 1 kilogram. Right, just have a look at those. Have a go at these. You're converting the grams into kilograms on this side, so you're going to have to divide by 1,000 to find your answer. And on this side, you've been given the kilograms, so to convert those into grams, that's right, you multiply by 1,000. Pause the video and have a go now. Excellent. I just wanted to remind you about these MathSpot manipulatives. So MathSpot is a website, and you can get on that website quite easily. Let's have a look here. I've got it up, but if you didn't have it up, you could simply put into your browser or Google MathSpot, B-O-T, and then I'm going to put in the word manipulatives, M-A-manip, and you can see it comes up on the search. Third one down here is MathSpot manipulatives. If you can manipulate something, you can move it around, and these are really handy. So top hit here, Maths Box Manipulatives. I'm going to click on that one. And here we have lots of manipulatives. If we just ignore the advert at the top, if we can, go down to here. Today, we might be using the fraction rule, which I will show you in a minute. But if you're doing any addition or multiplication or subtraction, and you like looking at the concrete blocks that we sometimes use, get rid of that advert. You can see that you can start adding up if you've got 2,112. So at the moment I've got 2,112. Can I have another one, please? Have another one, thank you. And I wanted to add it to 1,400. I could simply put these down here, put the 1,400 down here, 1, 2, 3, 4, and I can start to add things up. Okay, so that's a good concrete way of seeing things. Let's look at another one. 100 square. Lots of people like 100 squares. They're useful. You can click on things here to hide things, or you can change things if you want to. You can change the number of columns. Quite a few things you might quite like in here. It helps you work with numbers. The number frames, a lot of you will be familiar with these. I've got the 10 here. I've got a 6 there, so I can make 16. So I wanted to add 16 to 14. I would need another 10, and I would need, let's just move me. Can I move me? Yep, there we go. 10 and a 4. Okay, so I've got there 16, add 14. I can put that on there and I can see how big that gets. That is actually the same as a 10. So using these to add and do maths is really handy. Last one I'll show you is the fraction wall. So we're going to use that today. I'll come back to this during the lesson if I get me off the wall there. Remember, this fraction wall shows a number line really. Down this side here of the fraction wall, sorry, the left-hand side over here, you have got, you have got 0, and it goes over to the right-hand side here where there is 1. So this is a fraction wall. We're going to use that in a moment. So I'll come back to that. Okay, MathsBots Manipulatives, very handy for lots of the work we do. Quick reminder of some of the things we've done. You'll remember this poster where we're looking at the numerator and denominator. 4/4 make 1 whole. At the top here, we've got showing half in different ways, half a square, half a circle, half a triangle. If we look at this as a group of shapes, you've got 2 triangles, a circle and a square. So we could say, because there's 2 triangles, half of the shapes are triangles, a quarter of them are squares, and 1/4, because the 4 underneath each of these fractions represents how many shapes, the group altogether, and we can see that there are 1, 2, 3, 4 shapes. And we've got equivalent fractions down here, circles. You can see each circle is shaded in half, but on this version here, the circle has been divided into 6, so the denominator is 6, that's how many we've got altogether, and then the 3 on top, the numerator, is how many we're talking about. And it's a little fraction wall that we did as well down there. Okay. More fractions work where we're looking at fractions of amounts. We don't need that today. So we've got to look at how we can represent fractions in different ways using images and comparing fractions. So to do this, we're going to have to know what these symbols mean. They're 2 mathematical symbols. They mean different things. Can you remember? I'll put the third one down. That's easy. So we have got is less than. Okay, this one is less than. That's not very good writing. See if I can write that a little bit better. Doesn't like my S's. Is less than. Squeeze that in. And this one is greater. This pen's not so good with my writing. Let's do writing that's not joined up. That's better. And then finally, of course, we have equal to. So using these symbols, we're going to have to compare different fractions. Fractions are also represented by pictures as well. So if we look at a couple of fractions, say for example, we've got 1/6 and we've got 1/2, we need to think what symbol could go in the middle here that compares them. I want to know which is bigger, which is smaller, which is greater than, which is less than. So looking at a 6½, you go to your fraction wall. If you can't find this fraction wall on your computer, you should be able to, but if you can't, if you just type in fraction wall into Google, you'll find one like this. You might not be able to move it around like this one, but you'll certainly find one. And we've got a 6½. So if I take out 1/6, 1/6, if I take out a half, I can see if I'm looking from side to side that the half is definitely bigger than the 6. So in my maths, I can say that a 6 is going to be smaller. Here it is. The 6 is definitely smaller, is less than. So there's my symbol, less than. Likewise, if I had a quarter and I had a fifth, again, I need to think what symbol goes in between those, a quarter and a fifth. Go to my fraction wall. I could take out a fifth here, 1/5. I could take out a quarter. And I can see that, in this case, the quarter is bigger. So the quarter is bigger than the fifth. So I can say a quarter is greater than, in which case is the symbol for greater than. Notice they're facing different ways. Often we remember this because we think of the symbol as a little face. So here's the crocodile, and he is facing the bigger thing. He wants the bigger number, or in this case, the bigger fraction. And here he's facing the half because the half was the bigger fraction. So that's how we can remember and how we can work out which is bigger and smaller of fractions. Before we look at that, I just need to, let's just clear this off. And we'll look at fractions represented in shapes because we'll be doing that today as well. I'm on now. And we're back. Okay, so for example, you may be given a shape. So if I've got a shape like this, and it's been divided up into different parts like this. Each part I'm trying to draw exactly the same so that we've got the whole thing, which is divided into 3, 4, 5, 6, 7, 8. 8 parts altogether. So my fraction is going to be something over 8. So I need another round number on top. Whether it's written like that or whether it's written like this, it's a fraction something of 8. If in the picture of all of those 8 parts, which represent the whole, this is the whole, 3 of them are coloured in, this one, and this one, I would have to write down that 3/8 are shaded, or it would be like that. Okay, you might get something with a circle instead. It might not be a set of blocks like this one at the top. You might get a circle, where almost a circle anyway, where it's divided into 3. It's 3 parts. The whole is divided into 3 parts. The whole circle is 3 parts. So the fraction is going to have a denominator of 3. That is how many there are altogether. And if I was to shade in, how many should I shade? I'm just going to shade in one of those pieces. That would be 1/3. Okay, so that's basically what we've got to look at today, whether a fraction is less than or greater than, and also what the picture represents. How many parts are there altogether? In this one, there were 8 parts altogether, so the denominator was 8. And 3 were shaded in, so the numerator is 3. And in this example down here, we've got 3 parts altogether and 1 shaded in, so the 1 goes on the numerator at the top. Right, have a go at those. Putting the symbol, write these out into your book, 1 to 4 and 9, 10, 11. Making sure you put the correct symbol in there, which way is the crocodile going to face. And then if you want to go spicier, we have these. Notice these are not called unit fractions, so they're 2/5 and 7/8. So because the number on top, the numerator, is more than 1, we need to drag more than 1 out. 2/5 and 7/8 would look like this. I've got 2/5 here. Put those together. They have to be touching. Now I want 7/8. 1, 2, 3, 4. Move me out of the way. 5, and I can see that the 7/8 is bigger than 2/5 already. 6, 7. 7/8 is greater than 2/5. So 7/8, 2/5. Which way round am I going to put the symbol? Make sure you get it right. Okay. Last but not least, something spicier is representing these as well. The spicier work is representing these as fractions. So here I'd have to think how many altogether. 1, 2, 3, 4, 5, 6, 7. Where am I going to put that number 7? Is it going to go on the top, which is the numerator, or is it going to go underneath, which is the denominator? And then I've got to think how many are shaded. Well, only 1 is shaded, so the number 1's got to go somewhere. So I'm going to have a 7 and a 1. I've just got to write down the fraction that that's representing and do the same for all the shapes. Well done. If you want to go super spiciest, then you've got to use the images from the spicy learning to write out some equivalent fractions. Images from the spiciest lesson. Let's have a look at that. Here's the spicier learning. Equivalent fractions. What were they? If you remember, that's fantastic. If you don't remember, I'll show you now. Here we have a fraction represented in a picture. I'm going to do number 13 as an example. Let's draw that out. This is number 13. What could we say is an equivalent fraction? I can see that in 13, give the answer away now, you've got 2 of them shaded in. So I've got 2 shaded in, and there are 3 parts altogether. But I could cut that up. I could slice it down the middle here from left to right. Let's get a different color actually to do this. Yeah, what color do I want? Let's get a nice red. We can see that. Now I can put a red down the middle there. And now I can see that there are 6 parts altogether. 1, 2, 3, 4, 5, 6. So the 6 would go underneath. That's the denominator. How many are shaded? Well, if I look at the blue squares which are shaded, I've got 1, 2, 3, 4. So 4/6 is the same or equivalent to 2/3. So I can put a little equal sign in the middle there. And that's how we do equivalent fractions. You can take more images from here, more answers from this work, and tell me some equivalent fractions. Okay, well done, guys. And I will see you next time.